Okay, so today's kind of the last day of this stuff that we're talking about here with doing these conditional statements and all of that. So we're gonna go over some properties to be able to use on our what we're going to talk about today. So today we're focusing in on doing these two-column proofs, and we're doing it with algebraic statements today. It's going to be fairly easy, but it'll get you introduced to the idea of how these two-column proofs work. Okay, before we do that, we have to have some stuff to base this off of. All right, so several properties. The addition property of equality says this: if A equals B, then A plus C equals B plus C. Okay, so in that statement, what is the hypothesis? A equals B. What's the conclusion?
A plus C equals B plus C.
A plus C equals B plus C. Okay, then the subtraction property says this: if A equals B, then A minus C equals B minus C. Okay, the multiplication property says if A equals B, then A times C equals B times C. Okay, the division property says if A equals B, then A divided by C equals B divided by C. Okay, so those are just the basic ones, but we have them defined now so we can use them in our proofs down here. Okay, the distributive property says this, that if you have A times B plus C, that equals AB plus AC. Okay, next one, the substitution property says this: if A equals B, then A can be replaced by B. Okay, the next one is the reflexive. Now this one's kind of weird, seems weird, but it just says that A equals A. Anything equals itself. And we don't really need that for what we're doing today, but in a couple of weeks when we're talking about triangles being congruent to each other, we will need this property right here. Anything's congruent to itself. Okay, next one is the symmetric property. It says this: if A equals B, then B equals A. All right, then the last one, the transitive, says this: if A equals B and B equals C, then A equals C. Kind of like a middleman there. B's the middleman. Okay, so we have stuff defined here, so we can use these now as we work through our algebraic proofs here. Okay, so again, what I'm doing here is just getting you introduced to the idea of these two-column proofs. Now, they'll always have this. They'll have the given and what it is they want you to prove. And it's not necessarily always this way, but pretty much it follows this. The given is where you're going to start. And the prove is where you're going to end. Okay. So they've given us something, and then they're telling us what they want us to prove, where they want us to end up at. Now, in this two-column proof, the left-hand column is your statements. That's what you're saying is true. The right-hand column is your reason. So it's why that in the left-hand column is true. It's your reasoning. It's why that's true. So on the first line, it says 3x plus 12 equals 8x minus 18. That's right, thank you. Okay, so why do you think that's true? 3x plus 12 equals 8x minus 18. Why is this statement true? Because why? Okay, so this one's kind of weird. I mean, you'll understand what I mean in just a second, but how do I know that that is true? The reason I know that's true is because that's what they gave to me. Okay, this one's weird. This is true because it's what's given to me. See how this matches exactly what's given? That's typically the way you're going to start these proofs. You're going to start off with what you're given. And that's how I know that's true, is because that's what they gave to me. All right, so next thing I want to think about, going from the first step here, from the first statement to the second statement. So let's just think about what happened in the math. What did they do going from the first step to the second step? Okay, so they dealt with the 3x. So how did they deal with the 3x? They subtracted 3x from both sides. So on the left-hand side, if you have 3x minus 3x, what happens there? It zeroes out. So on the left hand, that's why there's no more 3x, because that's zeroed out. On the right-hand side, if you have 8x and you subtract 3x, what does that leave? 5x. So that's what happened there. So going from the first step to the second step, what did they do?
Subtraction.
They did the subtraction property. Okay. Next one, going from step 2 to step 3. What happened in that step? Good. So we're trying to get the x by itself. So we want to deal with that negative 18. So we add 18 to both sides. So what did we do? Or what did they do? They did addition. Okay, they added that 18 to both sides. That's why it's 30 now on the left-hand side, because the 12 plus that 18 gave you the 30. And the negative 18 plus 18 zeroed out. Okay, now going from step 3 to step 4, what's happening here?
They divided by 5.
Good, they divided by that 5, so they use the division property here. Now, this may seem like we're splitting hairs here, but with the way that work has worked out, it got us to 6 equals x. But what I want to prove is that x equals 6. So what I want to do in that last step is I want to take it and I want to flip that to where instead of it 6 equals x, I want x equals 6. Which one of those properties did we apply there? Yep, right here, the symmetric. If a equals b, then b equals a. That's basically saying you can flip them. So on that one, we applied the symmetric property. Okay, now when we get done, we're going to draw a little box. That's what you do when you get done with a proof. When I was in college, I had a whole bunch of classes where we had to do proofs. One way we ended it is with QED. That's another way you can finish up a proof.
What does that stand for?
I don't remember what it actually stands for, but it's an abbreviation of a Latin phrase that basically means that which was to be proven has been proved, or something to that effect. We'll just draw the box, though, as we go through here. All right. Next one. So the first statement, 3k plus 5 equals 17. How do I know that statement is true? Because it's given. Exactly. Okay, from step 1 to step 2. What happened in the math there to get from step 1 to step 2?
Subtraction.
Subtracted 5 from both sides. Okay, so we applied the subtraction property. And then from step 2 to step 3, what property was applied? Division. Okay, now does the last step here match up to what we were trying to prove?
Yes.
Yep, so we got that done. That's what we want. Done. Okay, now we're going to do the work ourselves. So what do you think I'm going to write as my first statement here?
7y.
Yeah, he jumped to the next one. Negative 6a minus 5 equals
Negative 95.
negative 95. Okay, good, but how did you get that? Did you just guess about something?
It was given.
Okay, that's true because it's given to us. All right, so now let's think about what are we trying to prove here?
A equals 15.
I'm trying to prove that a equals 15.
So we could do add 5.
Okay, good. So we're trying to get a by itself, so I want to add 5 to both sides. So if I add 5 to the left-hand side, that negative 5 plus 5 is what's going to happen? It zeroes out, so that just leaves a negative 6a. Then on the right-hand side, negative 95 plus 5 is what?
Negative 90.
Is negative 90. So what did we do there?
Addition.
We did the addition property.
Now just divide.
Okay, good. So now I'm going to divide by
6. Negative 6.
negative 6. Good. So when we divide by negative 6 on the left side, negative 6 divided by negative 6 is 1, or 1a, same thing as just a. And then on the right-hand side, negative 90 divided by negative 6 is what?
15.
Is 15. What property did we apply? Division. And that better be 15 because why? Because that's what we're trying to prove right there, right? So we got that done. Okay, good. Okay, I'm going to skip that next one and let's just go to the last one here. Okay. So what's my first statement here?
Given.
Okay, so tell me what it's going to be.
3 parentheses 5x plus 1 close parentheses equals 13x plus 5.
Okay, good. All right. How do you know that's true? Okay, because it's given. All right. So what am I going to do first in my math here? Okay, good. So the 3 distributed in is going to give me what on the left-hand side?
15x
Fif-
plus 3.
15x plus 3 equals 13x plus 5. So what did I do going from the first step to the second step here? Okay, I applied the distributive property. Okay, good. Now, what's going to be my next step here? Okay, and also we're trying to get to x equals 1, so I'm solving for x here. So, good. We're going to get the x's together, so I'm going to subtract 13x from both sides. So if I take 13x from both sides, what's that going to leave on the left-hand side? So I still have, so that leaves a 2x still with the positive 3. On the right-hand side, if I take 13x away, what does that leave?
5.
It just zeroes out, and so that just 0 plus 5 just leaves 5. So what property did we do there? We did the subtraction property.
Can you have 2 reasons on one? Like 2 steps?
No, you want to take each step individually.
Oh.
Yeah, because I can see what you're saying there, but... Okay, so what are we going to do on this next one?
Subtract.
Yeah, subtract. We're going to take 3 from both sides. So if I take 3 from the left-hand side, what's that going to leave? 2x. Take away 3 from that side, it leaves 2. We applied the subtraction again. Okay, then what are we going to do? Divide by 2 on both sides. And so that's going to leave x equals 1. We apply the division property. Is that what we were trying to prove? This matches this. Good. Done.